Welcome to Transmathematica School. I'm James Anderson. If you toss a coin, it might come down heads, or it might come down tails, or it might come down on its edge, which is heads and tails, or it might not come down at all. These four possibilities are a tetrachotomy. But what has tetrachotomy to do with transmathematics? That is what we'll think about today. Let's start with a monochotomy, one class. For example, the set of real numbers. It's one thing, a set full of things that are all of the same kind, real numbers. French people split the real numbers into a dichotomy, two classes. They have positive numbers, which are numbers like 0, 1, root 2 and pi, and negative numbers, which are numbers like -1, minus root 2 and minus pi. Notice that French people say that 0 is a positive number, and that affects the whole of their mathematics. That's just the way they do things. English speakers do it differently. We have a trichotomy of three classes. Positive numbers like 1, root 2 and pi, negative numbers like -1, minus root 2, minus pi, and 0 itself. In fact, there's an international agreement that says the strictly positive numbers are all greater than 0, the strictly negative numbers are all less than 0, and 0 is just itself. It promotes international harmony, but transmathematicians do it differently. We have four classes, a tetrachotomy. We have the strictly positive numbers, which are all greater than 0, the strictly negative numbers, which are all less than 0, 0 itself, and nullity itself. Tetrachotomy is axiom 30 of Transreal Arithmetic. It's built deep into the heart of Transreal Arithmetic. I used to call this axiom quadrichotomy, but when I was making the YouTube video, I realised I should use the Latin root for 4, not the Greek root. You'll use tetrachotomy every time you do transmathematics. If you forget what tetrachotomy is, watch this video again, or just pick it up as you go along. I'm researching tetrachotomy in logic. The two values, true and false, can be combined in four ways. Just true and just false make up Boolean logic. If you use Boolean logic, you're guaranteed to fail. You'll fail on a contradiction. Now, computer scientists use Boolean logic all the time, and most of the time they don't worry. The reason they don't worry is that everything they do happens inside a computer, and they've gone to a great deal of trouble to arrange that bits are either true or false and nowhere in between. That's fine until computer scientists want to prove properties about their programs, or until they want to implement a logical language like Prolog. Then failure occurs. Mathematicians deal with contradictions. There is a method of proof by contradiction. There are paraconsistent logics which reason over contradictions. But even if you work with just true, just false and contradiction, you're still guaranteed to fail. You'll fail on gaps. Gaps are dealt with in mathematics, sometimes explicitly, sometimes as non-existence. So all of these four values, just true, just false, contradiction and gap, are dealt with in mathematical logic. But I think there might be a neater way of doing it, and that's what I'm researching. If you're an expert in logic or set theory, I would love to talk to you about this. Tetrachotomy is built into Transreal Arithmetic and everything that follows on from that. But it might be deeper. Tetrachotomy might be built into logic. It might be built into the foundations of mathematics. You're welcome to watch these videos for their entertainment value. But if you want to educate yourself to be able to divide by 0, you need to do the exercises that are coming up. I will put the answers at the end of the next video. Then come back here and put your score in the comments. It will let me see how I'm doing at giving you an opportunity to learn Transmathematics. While you're about it, watch the video all the way through a second time. It will help you remember what you have learned. If you got a question wrong, try it again. The last question is an alpha sting. It is ridiculously hard. The point of it is to give you an opportunity to explore what you have learned. If you can solve it, you're brilliant. Seriously, you are. So here are the questions. Say whether the following are less than 0, equal to 0, greater than 0, or equal to nullity. 9 3/4, 0, minus 6, 0 divided by 0, 3 minus 2, 2 minus 2, 2 minus 3, infinity, minus infinity, minus nullity. Check the description below for links to more material. Leave questions in the comments. Tell your friends and enemies about Transmathematica. Subscribe if you still haven't. And if you want to support the advancement of science, see the About tab for donations. Bye for now.